at the Palisade Park, which is on the previous video, Neil Beekman gave me this little set of pictures, which we'll put on the video and we'll send on the Stunt News. This guy's name is Izzy. He didn't write his last name on the, and I'm not sure I know it, so I won't put it in, but Izzy built this gyro, and apparently they're having some good laughs with it out at Flushing because it has never gotten off the ground. It's really a car. So Izzy, I don't know if you really want to send this in the Stunt News or not. I don't know. Anyway, this is Neil Beekman's Air Force. We got to see his Cardinal fly at the Pal Park meet. We also were amazed at the popularity. Neil had the first one of the flight streaks, the pre-made flight streaks that Top Flight sells. We were amazed how well they flew. Another part of Neil Beekman's Air Force of about 30 airplanes. And I think it would be unfair to not mention Neil being a true hero of the 9/11 tragedy in our area. He's a retired fireman who gave about 40 days, I think even more, to helping recover bodies and clear the rubble. Anyway, even more of Neil's Air Force. Neil Beekman got a special award at Rojett, I think 2 years ago, for his efforts. And Al Knight and Mike Cooper. We got another quick set of photos here from our friend John Hatt. John Hatt is up in Halifax, Nova Scotia, and these are some of the pictures of planes from his Air Force. This is the inside. It looks like an inside of a Corsair. Pictures from his shop. John runs a hobby shop. He has built the Miss Ashley and several other stunt ships. This is a real nice set of photos that he sent. This is his latest creation. A stunner that he's working on. No captions with the photos, but I think we can pretty much look at it and see it's a kind of a forward canopy jet looking fuselage. And if this is any indication, as it was with John's Miss Ashley copy, it'll just be an absolute super finished aeroplane. From Nova Scotia, John Hatt. Now let's get back down the shop. We have a mountain of stuff to do. Well, because we're coming up on the end of the 2003 flying season, in fact, I think there's only one more meet left, the Circle Burner meet, and the weather is quickly turning to fall, leaves are falling and whatever. We like to look back at the 2003 season, and I've put all of the B-25 flights that I have, virtually all of them, contest and otherwise, on one tape that I call it B-25 Memories tape, and if anybody, of course, would like a copy of that, just mention it to me. I think that's going to, somewhere down the road, be something very nostalgic and a lot of fun to work on. We're just blown away by how popular the Strega and the molded top blocks. We, for all purposes, have to make one a day just to keep up with inventory now on the Strega top blocks. So I hope that information is going to serve the stunt community well, and obviously the Strega is off to a flying start, probably the best start I've ever seen for a kit as far as sales go. And of course Ken Teiser's success in 2003 didn't hurt that one bit. One of the sad notes of 2003 was how little good weather we had, and we really were hoping we could work with our Sato 91 and our Zetron a lot more. Well, we just didn't because of the time constraints. You know, what really happens to all of us is we run out of life, we run out of time. We make a lot of grandiose plans, but somewhere down the road you run out of life. Les and I in the past year have done a lot of experimenting with foam wings in various ways to try to make them a little bit easier to make and a little easier to finish and possibly a little lighter. But what we've tried to do is we're going to try to prioritize this. Now Les gives shotgun lessons and he's going to be done in a week or two. We hope we're going to get back to working on this project full-time. Obviously, the problem is, like everything else, we run out of time. And especially this summer where we lost about a third of it to weather and another third of it to other various things like renting our apartment units, things beyond our control. But we are ready now. We're as ready as we've ever been to aggressively get started on laying out a program for our building season. We know there's certain parts now, like the Strega top blocks, that we're going to have to be making every day. So we try to lay out the day. I try to lay out the day so that in the beginning of every day, I can do all the molding, lay up the molds, whatever parts I sell on a regular basis. And then in the afternoon or later in the day when we generally answer the phone, we hope we're going to get started on some of the construction details. Russ is finalizing the plans. Elliot Scott is working on finalizing up the B25 plans. But again, please keep in mind we have so many projects to work on. And I'm hoping we're going to be having some other shop projects along the way. Several other people have expressed an interest in coming down to the shop and working and being part of our video series, and we'll enjoy working with them. One of the things I'm always looking to do as a side to flying and enjoying the flying and interacting with my fellow flyers, of course, I'm looking to upgrade the equipment we use if it's at all possible. Now, one of the things we ran into in the year 2003, and several other people ran into this, where the zip tie manufacturers, we used to buy these thousands of zip ties basically at Home Depot. And what's happened in the meantime, I think Home Depot, because the price is so cheap, you get 1,000 of them for a couple of dollars, I think they've really cut the quality back. So what I did is we had these at the team trails, I had Kent Tyser do a little investigating. He works right down in this part of the country, and he got us a catalog of, these are really high-end zip ties and connectors. Now Les is going to go through here, of course. Well, what we found out right away is that not all zip ties, of course, are created equal. They have the ones that, let's call them Home Depot ones, very inexpensive. The problem is, in our case, what was happening, the way Miss Ashley is all cowled in, the zip ties were getting so hot they were getting brittle and breaking, and then, of course, leaking oil all over the side of the plane, and among other problems that could happen. And it's always the ones up on the header that are a problem. So by Kent investigating this, he came up with, and I would suggest, if you're really interested in finding out the bottom line here, you can call Kent Tyser up, not only to get a couple sets of lines, he's doing a great job with his line wrapping and making lines available, but he did manage to turn up some zip ties that are rated for 300 and 400 degrees. He's got some of these, and we haven't tried them all yet, and once we find out which are going to be the best, but in other words, the ones we were using were rated for 18 pounds. And it wasn't that they weren't strong enough, the heat was deteriorating them where they would get brittle and break. Well, now we have some, and Warren Walker got me some supplies too that I'm going to try, that are rated up in the 300 and 400 degree range for extended service. So what I'm suggesting everybody do is we'll just wait until Les figures out what we're going to order here. But there are a lot of choices, and you can see if you want fancy ones, I would suggest you stay away from colored ones. And it seems like the white ones were a little bit stronger than the black ones. Pick up one of these catalogs, and you can call them for a free catalog. The catalog is free. It's Panduit 800-777-3300. Ask for customer service. Kent didn't have any trouble getting a couple of catalogs for us. And I would suggest as time goes by we find whichever are going to be the upgraded zip ties, and we'll pass that information on to you as soon as we do what we always do, an extensive testing of the product. And we'll share it with Richard Oliver and all the people that seem to team up and work together to share things. Bill Hummel emailed me with, of course we saw him at the contest Sunday, he wanted me to pass this little tip on. Again, that's what we're trying to do, is pass on, basically you could call this section to take things we learned in 2003. One of the things we had a motor that was in Strega, a side exhaust Rojett 61 that Rich Oliver had, when Rich was up here, he had flown and passed on to me. I passed it to Brian. Brian passed it to Bill. Bill ultimately bought it and has it in his Thunderbird. Now, it's a side exhaust engine. He's using a Rojett muffler. So, 2 days before the contest, he calls me up, and he is madder than you can imagine. My engine just stopped running. Oh, what a problem I'm having. Oh, da, 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 da. And I asked him, and I said, well, what's the first thing you do when you're trying to diagnose a problem? Fuel. Well, here's what really happened. He was at the field, and he ran out of fuel. And he borrowed some fuel, thinking all fuels are created equal. Well, and never realized that when he filled his jug, that was when the problem started. And soon as he put a fresh gallon of fuel in it, instant problem went away. So be aware, if I use an old fuel, especially fuel that's been in an uncovered can, or when people take the top off and suck fuel out with a siphon, you're exposing that fuel to air constantly. That's why we try to encourage people to use the fuel pumps that we do, where the fuel is never exposed to the air, only the one time you open the jug. So fuel turned out to be the culprit there. But also, as long as we were doing this, I told Bill what I do is what I call my little diagnosis. You have a motor that's running fine, and all of a sudden it isn't running fine. Well, what do? Fuel would be the first thing to check. Put a new plug in. Plugs are like windshield wipers. They don't last forever. A lot of times even that doesn't cure the problem. Look at the fuel filter. Clean it. Also, another test, and this is a real good diagnostic test you can do right at the field without even taking your toolbox. Open it up. Let me just sketch out. This is one of the diagnostic things that I would do on any plane. Plane all of a sudden is running erratically. What happened? What changed? Okay, what I like to do is, normally the bottom vent on my planes gets capped off. I would fill a tank with fuel. On my planes, the uniflow pipe is exposed, and that's the only outlet to the air. Run the engine at the normal RPM you run it at, and put your finger over that. So in essence, you've blocked off all the air that can get into the tank. Now the motor will just incrementally go faster, 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 and then shut off. What happens if it doesn't shut off? If it doesn't shut off, you know you're dealing with a leak in the tank, or the tubing, or the filter, or you're in some way letting air into that system. So it's such an easy thing to do. You can do it right at the field. You can do it periodically. A lot of times what I like to do, and this is something I usually do in cold weather, that first start of the day on really cold weather when you have to flip the plane upside down to start it, what's a nice idea? Fill it with fuel. Start it upside down. Put it back up on its feet. Let it run a couple seconds to clear out all the oil from the exhaust system. Warm up to operating temperature, and just cap off that uniflow. Now, if you had muffler or pipe pressure, let's just say you were running pipe pressure, it's just as easy. Just pinch the line with your finger or a forceps. But in essence, you're starving the tank for air, and it's a perfect test to see if, when you're diagnosing a problem, and in Bill's case, he hit it right on the first shot. That's always the best. But anytime you have a really lean run, good idea to take a look at the plug. What happens to a lot of plugs is, if you look at them and the little coil on the inside will all of a sudden be off to the side. Well, it's a good idea just to replace the plug. I've seen people take pins and try to get it back in the middle. You know what? Buy a plug. That just seems like poor economy. Fuel filters, and we've been using the little Rojett filters. They come apart, flush them, clean them, put them back together. So this is a good little diagnostic thing that can serve everybody, no matter what engine, no matter what plane, no matter what exhaust you're using, no matter what fuel you're using. These little things will really go a long way toward diagnosing a problem and getting rid of it in as short a time as possible. Good little tips from Bill Hummel. Now, one of the most mystifying, talking about, this is my information now, over the years, that would be very mysterious to me, is I would have, I will make an example. This would be the previous year's plane, tank, prop, fuel filter, fuel lines, everything. That whole package, I'd fly the season out, and then over the winter, of course, I'd make plane B. And what I do is I take that whole package and install it in the new plane, thinking and hoping, of course, that I would not have to break an engine in, I would not have to shim a tank. That would save me a lot of time. But a lot of times, here's what would happen, and it happens more often than you think. The motor just wouldn't run right in this plane. It would run erratically, where in this, it would run dead smooth. Well, what you're dealing with almost every time is a thing called resonant vibration. RV for short, resonant vibration. Resonant vibration means that this one combination in plane A, and this is especially true of profiles. A motor will run like a Rolex watch. You put it in another ship, it doesn't want to hold a needle setting, other things happen. A lot of times it can be that the tank is loose or not shimmed properly, or that you're just dealing with resonant vibration. That all airplanes, no matter how solid they're built, they have a resonance and then it'll stop. If you look at a tuning fork, it tunes at 1 RPM and then stops. Well, it could be, and this is just my feeling, that maybe this plane tuned in at 10,000. Well, in this plane, I'm running this one tunes in at 9,500. They're like two tuning forks. And what happens? The fuel gets foamed. Now, a good way to analyze this and figure it out is the first thing, run the motor at a different RPM. In this case, we could run this at 10,000 or this at 9,500, whichever the bad condition was. Change the vibration RPM. Like a tuning fork, it's only going to tune at 1 RPM or one small range. So a lot of times what will help is going from a 2-blade prop to a 3-blade, a 3-blade to a 4-blade. A lot of times just changing to a little more pitch or a little less. So in some way, change the RPM that you're running the motor at. And a lot of times that'll cure the problem. If it doesn't, then you have to resort to things which I've had to in the past, of adding some beef to the nose, getting some plywood inside the tank box, and somehow beefing up the part so that what this does, it changes this range. It changes the range at which it resonates. And if you ever want to see what happens with Venetian blinds, they all go one way, they all go one way, they all go, and you just take one and pull one out in the middle and they go and stop. Well, that's what we're trying to do. Resonant vibration, especially in profiles or planes that are built without really solid nose construction. Now, can be a real problem. One of the things that we've really, I guess, been fortunate in, our carbon models have been really not prone to resonance, and I think the reason is they resonate in a range way beyond what we normally use. It just happens that typical wood construction seems to like to resonate right in the range where people like to run their motors. But we've been lucky with the carbon so far. It seems like we're way off the scale, and we've never had, even with the 4-stroke 91, never had to deal with radical resonant vibration. But it can happen, and this is just one thing you can try to help, really, to make your life a little easier, or save the plane, save the day, or whatever. Just being aware of how it happens, you're way ahead of the guy who just doesn't understand resonant vibration. Now, at this year's team trails, we had quite an interesting thing happen. Of course, we weigh all the models, so we can tell, and believe me, every one of them is probably lying by a little bit. But when we put them on the scale, we get a real idea where they are. And I've always been a believer in that, in my case, the kind of models I want to build and maintain, that they really don't want to be the heaviest ones there, but being the heaviest one isn't a terrible handicap. And in this particular year, the heaviest model there, I was tied for the heaviest with Paul Walker. If I believe, I'd have to look back. We had the two heaviest models there, and Paul, of course, flew well enough to be on a team. But the weight didn't keep him off the team. Another interesting thing, Billy Rojett's was among one of the lightest, but not the lightest. And I'm bringing up a good point here. I think Gieschke's was light. Several of the models were under 60 ounces, but the ones that made it onto the team, Paul's being the heaviest, Billy's being the lightest, and Ted somewhere in the middle, what does that tell you? It probably tells you that if you're a good enough flyer, the weight is not going to be a problem. And you can fly it like Bob Barron did many times, fly a relatively heavy model or a really nice light model. And that even goes in with power choices. If you go in 2-stroke with a pipe or 4-stroke, it's really the flyer and the experience and the talent he brings to the table that far outweighs whether a model is light or heavy, and either way, you can still be a team player. One of the things I've been blown away with this year was Mike Palco's electric, and in the last tape, you've seen how far he's come. He's actually getting full stunt patterns now. So for lack of a better word, we're going to call it Palco's electric. In talking to Sergio, and really Sergio is being very aggressive and busy about locating the batteries, which are the heart and soul of this whole operation. Mike has been using nickel metal hydrides. They're relatively inexpensive, but really not state of the art. There has since become another choice of battery, and I'm not sure exactly how you define that, but there has been a phase, I'm going to call it a phase 1, which has evolved into a phase 2. So we're actually looking at Mike's plane. Mike could upgrade this if he wanted to spend the money. 2 steps, but what Les and I want to do, and we're doing it with Sergio's help. Sergio is waiting for the next level to come out. He feels in the next 6 months, or before Christmas anyway, there's going to be even another better choice that'll be commercially available. Now, the motors are already world class. The brushless motors are out of control good. It's the batteries. When you go from nickel metal hydride to these other choices, and now there's really looking like on the horizon there's going to be a third choice. So even though Mike is getting full patterns, Mike will be able to upgrade. And when Les and I we're hoping over the winter we're going to have enough time to frame up a basic electric plane, we're hoping we're going to be able to use, if they become available, this third option. Now keep in mind, in the world of electrics, things change on a daily basis. Things become obsolete, just like computer systems. All of a sudden you have Windows 8, and all of a sudden you need Windows 9. Well, because we're doing it as a fun project, we really are not rushing, and we wouldn't be able to fly in the winter anyway, more than likely. But we're really looking forward to this next step, and Sergio has assured me that he'll be able to pick out all of the components we need. We won't be buying a lot and throwing them away, and of course we'll have all that information on the upcoming subscriber videos for anybody that really likes to share the experience and the adventure with Mike, and what will be Mike, Les, myself, and Sergio very soon. Now, one of the things Joe Musco and I were talking about over this last weekend was, and it sounds hokey when you think about it, but the more I think about it, the more I like it. Now, both Joe and I have multiple Spitfires, and they are, in the case of this one, they are exactly as they were at the end of the season of '96, in this one's case. We have the lines, the handle. I would assume that by now the tank is corroded and I may have to make or replace the tank, but other than the tank, the motor still had really good compression. This is a Big Jim Tiger 60. And Joe and I had talked about something that maybe would appeal to you also, is we were thinking about having a nostalgia year where we go to the Nats and fly the planes we flew in '96 or '97 or whatever year, and just kind of recreate that year. Of course, you'd trade away some being competitive, but in our case, we're long since past the time where that's a factor. And I think we really both would enjoy. We have the shirts we wore. We have the, I have a feeling this plane might still be in the front row. I don't know. And it was the concourse winner that year. So, but a lot of, it's something that's crossed my mind a lot lately. And as I'm getting older and older, just coming up with new little projects, I just never stop thinking about little ways to enjoy the sport of model aviation. Now, for some people, it's just competition. For other people, it's just some other phase of it. In my case, I just love developing things that are relatively untried or new, especially the composite stuff, especially things like making these 5-blade propellers. What a job that was. Every time I make somebody a copy of that video, I get a headache. And that was the first time I had ever set a mold on fire. A long story. Maybe I'll write about that in Stunt News. But anyway, just a thought. Random thoughts tonight. What might be fun. Maybe it's something you'd enjoy too. Joe Adamusco seems to think that would be a great thing to do. And the more I think about it, the more I agree with him. Reliving the year of '96, just like going to your class reunion, I guess would be a good way to look at it. The year of 1996. Well, as you may or may not know, these are the commercial signals that you buy for an O-gauge model railroad. These are made by Mike's Train House. But the controllers for these are really something that I found to be really unreliable. And Sergio Zegras, he was just here the other night, and we looked at his prototype system. In fact, I have one installed now just to see how reliable it's going to be. He's making up what amounts to be something similar to a Zetron to control the signals. What these little signals look like on the model railroad, and they have a little detector that goes in between the tracks. And what happens when you cover that detector with a train, it's a photo cell. You can see the signal changes. Let me just put my finger here. So when I take my finger off, see, it changes. It knows the train's gone by. Now they make these in various, I guess qualities is the right word. But all of them, the best of them is not as good as what I want. Now Sergio has come up with one that runs on infrared, and we're going to be testing that real soon, that I think is going to be light years better than this ever was. And we tested it in a Fuddruckers, and everybody was looking at us like we were crazy. On the middle of the table, we had a signal and a crossing gate and one of these flashing things, and we had them all laid out while we were eating hamburgers, and everybody was looking at us like we were totally crazy. But hey. Anyway, another thing we're trying to work on, and as I've said before, there's just no end to the amount of things. My brain just cooks and fries and always looking for some new project to work on. But of course, at the end of every night, everybody knows what we do at the end of every night. We run the trains for about a half an hour, and that's a good way to relax, wind down, and get ready for supper. Hey, we really do have a lot to live for. Well, because we're near the end of the contest season now, we have an opportunity to do some testing for Rich Oliver, and let me lay out in a little storyboard what it is we're going to try to be doing in the next couple of days. Now, what happened in the last couple of months is we had a real good chance to do some testing on heads, Venturis, and pipe lanes. But what we did is we basically did all of that on Les's 61s. And Les had two of them. This is the 61 that we used at the team trials, one of them. This is one of the older style ones with the cast case. The one that has the bar stock case is still in the plane, and we're going to be looking at, I want to condense all the information for the 61s that we've learned onto one tape. But the information for the bar stock and this motor are very similar. They ran very similar. There wasn't a whole lot of world of difference between them. This motor is a little bit lighter, I think 6 grams lighter than the bar stock, if that's a significant thing. If you have a plane you're trying to get all the nose weight out, you might want the cast case one, but in either case, both of them are very similar. What I found is I had a stock head and a high compression head, and in my case I like the high compression better. Again, there are several choices. Rich can supply these heads now in various compressions. Keep in mind though, high compression head, Miss Ashley is a relatively large plane, a relatively draggy plane with a thick wing. And it's heavy. It's just under 70 ounces. Now, where this is leading me to go is with a stock, if you had a 60-ounce plane, 65, this might be a better choice. The thing I liked about having a high compression head in the plane is you could always add a few shims if you were running short on fuel or wanted to soften the power. What happened with the stock head, when I took out all the shims, I still wanted more compression. Again, Richard can supply them both ways, and keep in mind this applies only to the 61. 65, different animal. Now what we did is we started with 189, and these numbers may be off because I'm looking at Les's notes here. 204, 210, 215. We had 4 different Venturi choices, and we tried them all. What happened with the 215, we entered the area where the motor got unstable and was using too much fuel, so we basically settled on the 210 as being our first choice. So what this is going to allow me to pass on to you is what actually was my team trials motor setup. You can look at the motor runs on the tape and decide if they were appropriate for you or if you wanted something different, better, whatever. Now we also I had made several pipes and ran the lengths from 16 and 7/8 all the way up to 18, and we settled on 17 and 5/8 as the final that was working the best at Muncie. So here's what I'm suggesting you can learn from this. If you have a 61, this might be the setup you want to start with, and I know a lot of people have 61s. The high compression head, and in my case I had no gaskets in, took all the gaskets out. 210 Venturi, 17 and 5/8 pipe length. The prop, I have a gauge, and it's basically a 4-inch pitch prop. It's a 13-inch diameter. But if you want me to pitch a prop off of my gauge, I'll gladly do that for anybody, any of the friends we have. Here's the final piece of the puzzle, the fuel. Now it's just funny that we started this. We were going to try to spike fuel and then do a lot of different things and add this and add that, and we wound up using, as the final thing, 10% power mass to fuel. Now, with this setup that I'm showing here, What's nice is I think if you replicate this, you will have an excellent starting point for getting your 61 to run very well right off the bat, whether you're launching at 10.5. Richard launches a little slower, I launch a little faster. These are the numbers that worked for me, and I hope they're of some value to the people that now are running 61s. Now the 65 that we ran at the whole beginning of the season, actually, up until the team trails, where a 65 is not one of the options you have, 65 is just a little bit different, and here's what I think is different. Totally stock the way we got it from Richard, it just ran great. So we never really experimented too much with it. The only thing I did, and I didn't want to change the crank or anything because I wanted to have a database of stock engine stuff. But what I did do, I did the normal Venturis size changes. And we did this right at the field. But the one we didn't try, and we're going to try that in hopefully the next couple of weeks, because here's what's going to happen, and I hope this is going to work out well. It's something you can watch on video and see roughly how we do it. 189, 204, 210, 215. The 65 seemed to run the 215, and it really wasn't totally unstable, but it was bordering on it. It was bordering on the part where, right at about this size, you need pipe pressure. And I didn't want to run that. But I also didn't want to cheat myself. And I said, well, at the end of the year when I'm done, we're gonna do some more fooling. And I have this George Aldrich spigot Venturi that's gigantic, and I'll show it up on a video when we change it, and has a little spigot in it. George made this. It's never been in one of Richard's motors. It was in several of George's motors. It needs to run pipe pressure also. So we're going to probably use up some of the time left this season to do some testing. Now, whenever I ran my 65, one of the things, no matter what pipe I had on there, it always wanted to run the pipe length at 18. Anytime I shortened the pipe, it just got too racy. I always use Power Master fuel, 10%. And the nice thing that's different about the 65, it's just a full 13-inch by whatever pitch you want. In my case, I have my gauge, but it's about 4 inches. And the 65, because of the way it's designed, set up, or the cooling that a bar stock engine offers, really runs this big prop really well. But what we're going to try to do, and I'm going to try to do it as soon as the crank gets here. It's already left Texas. It's going to be a couple days, and I don't know what we're going to be doing in the shop in the meantime. But what we're going to do is in one swoop, we're going to change the crank in the engine to the lighter crank, and that saves just under a half ounce, 10 grams I think. We're going to change the Venturi, pull out all the head gaskets, get it as high compression as possible, and I've made a 6.5 ounce tank because it's going to want to use more fuel. But this will just be a test. We'll give it a couple days. In fact, we may, if it works out well, we will for sure then fly it at that last contest of the year. But if not, knowing what some of these setups are, and I would guess that a PA setup or any other pipe setup is not going to be a whole lot different than this. Now what's real nice, Richard is working on the same exact thing for the 40. Several people, including Bob Hunt, were running Rojett 40s. We need to have the same kind of numbers so that these packages, next year when we have our 40 ships done, we can basically share with people what we've learned and get it into their plane as quickly as possible without day after day after day of frustration, or without having to buy 6 tune pipes before you find the right one. So anyway, hope this is good information. As soon as the crank comes in, we're going to do the crank swap. The big spigot Venturi, I made a 6.5 ounce tank, and I hope it fits in there comfortably without doing a lot of gouging around. We always run our pipe at 18 with the 65, but that may change because here's what happens. As the Venturi gets bigger, you almost always shorten the pipe. These two kind of go hand in hand. So again, we may come up with a whole new set of numbers. We may come up with something that's a little bit better. We may come up with something that's not better at all. But one thing I know, with the weight out of the crank, and let me do a little storyboard on this because this is a whole separate issue. If you look at how a traditional stunt chip balances, what you notice is there's a lot less airplane hardware weight in front of the CG. I said it backwards. There's a lot more weight. But what happens is, if you can remove weight, and let's start with the most obvious thing. The plane is nose heavy, you want to get some weight out. You start at the front. The spinner is the first thing you try to change. Get the lightest spinner possible. Get an aluminum nut on the motor. In our case, we're going to have a crankshaft that's a ½ ounce lighter. So let's just pretend this is a ½ ounce, almost a ½ ounce anyway. Let's pretend that that's what happens here. That also means somewhere back here, and if we take it out back here, we can take out even less. We'll probably take out a ½ ounce off of the tail wheel and still maintain the same CG. So you see what happens? Now, we have a carbon spinner already, but if we can find something, the other thing that of course we already have a carbon tank in here, but if we were not to have it and we were able to pull out 1.5, just see what's going on. How much could we get off the back? Now, if there's nothing you can get off the back, in our case, we do have a brass tail wheel that we use to vary the CG, but you could also think about starting at the bottom of the plane and buffing off some of the clear, which is one of the ways of get the bottom of the plane, all the clear off it. But the relationship here, if you can, everything that you take off of this side, you can take some off of this side depending on where you take it off and still maintain the balance. So in our case, everything, that ½ ounce of the crank becomes 3/4 of an ounce. That 1.5 ounces for the tank becomes something more, because we're going to be able to, in the worst of all worlds, which of course take apart plane, we'll make a lighter tail, lighter flap, something behind the CG. But you see, it's like this relationship is always a balance, and there's always usually one or two very tiny variations. You can go a little forward or a little back, but there's a place where most planes really like to balance. Once you find that spot, then you can start nibbling away at getting some of the weight off, and in our case, I think when we're done with this whole thing, we'll have 2 or 3 ounces off the plane, which will be real nice, but if we don't, we know that wing handles 70 ounces very well. And if we can come up with some little, for instance, the crank and the tail wheel off the plane, we know it's going to be probably almost an ounce lighter. Anyway, this is what we're always fighting, and this is why a plane, and I'll just make an example of Dave Fitzgerald's plane, for instance, because you're constantly, after years go by, you have all these little things done. Usually with a new plane, you don't have everything off that you could get off. Well, this is why an old plane always seems to be, in terms of being competitive, an older plane is always a lot better than a new one, in my book anyway. Billy Woolridge's P-47, years and years of trimming and filing things off and getting it just right. Anyway, just some thoughts, some information. I hope this serves everybody well. Every time I look at Mike Palco's electric plane, or Sergio and I look at it together down here, we are just psyched about that. So many cool things happening. Look at this. Who would have ever thought years ago this would all be possible? Anyway, what I'm doing is I'm making up a dedicated video I have about 10 of Mike's flights all on video. One video with all of the flights on it, and I think that'll be something a lot of people will be interested in, just sharing and having, and I'm interested in it. Look at this. Is that cool? Anyway, more electrics from Sergio. This is what's nice as days go by, and you can just make shell after shell after shell. We got a nice supply of wood now to make these from Bill Hummel, and Bill has already told us that they fit really nice, so we're just going to keep making one a day, and I think that adds just one of the touches, a little upgrade to Brodak's Strega kit. Being able to buy shells is really a nice option. Saves a lot of wood too. This morning we opened up the mail and we have our brand new lightweight crankshaft that's going to go in a Rojett 65. So right after I have my coffee, I'm going to get the motor out. Now, Replacing the crankshaft, a lot of people don't want to replace it, or they want to have a professional replace it, but I want to show step by step. This is our 65 that's now a year old, and what would be involved in just a crankshaft replacement. Now this crankshaft is about 10 grams lighter than the original one. So getting some of the nose weight out of Miss Ashley, or whatever plane this, even if this winds up in a typhoon, we're not sure yet. But we got so many projects we're working on. One of the things, it's always better to get the weight out than to have it in. This is a Rojett 65 crankshaft. A couple of things that may be relevant. While we were storing this engine, of course we were using 61s at the team trials, I had put after-run oil in. After-run oil is typically red. It's air tool oil, in fact, that Les had gotten. So there's quite a bit of oil already in the engine. And I always cap off the openings, leave a glow plug in so that it stays relatively clean. And then in this case, I put it in a bag with other parts that I'm going to change. While we're doing this change out, I'm going to put the big spigot Venturi, and that's what a spigot Venturi looks like. Of course, we'll take this one apart. The spigot Venturi, because what we're going to do for this last little bit of the contest season, there's only one contest left, we're going to try the spigot Venturi, the lighter crank, and taking out all the head shims in one test. And then if it's way too powerful, which may be the case, one by one we can either put the head shims in or replace the Venturi relatively easily. And then the last thing, of course, this crankshaft is supposed to have a little bit different timing. Maybe just make a little bit more power. Not sure, but anyway, we know this one has the mild crankshaft in it, so we're going to be... The first thing is to take the motor apart. Once the screws are removed on a 65, this part very carefully, very gingerly, just take it out. It has an O-ring on it to make the seal. You can see how that after-run oil has gotten on almost every part, and that's good, of course. Here's your little relief, so you would know when you put this back. Index this goes up by the liner. Then we can see the old crankshaft in there. Now, once we pull the liner, we're going to have to take the head off next and take the liner up. I want to mark exactly where the liner is. There's usually a little scratch, and I'll put a little scratch of my own because I want to get an exact line up here. In fact, I'll take this out because I want to be able to look inside. Again, most of this is really, and let me just show you another little trick here. You can see this motor has had quite a few gallons of fuel run through it. But we're going to have to take the liner out so that we can remove the connecting rod. Right now, you can't put it at top dead center and take the rod off. I have. Check this out. He's got the little piece that was in the exhaust pipe. You dope, it's got oil on it. He's got my little piece of cotton with tissue paper with after-run oil on it. Oh, checky! You want to loosen screws. I mean, this is just like engine assembly and disassembly 101. Loosen one screw and then the one directly opposite. Loosen this screw. Actually, it's this one that should be. I'm looking through the camera lens. Loosen this one and the one directly across from it until all of them are loose. With 8 head screws, you almost never, in fact, almost never is not the right word, you never do get a warped head. This is a really superior design, a little extra work machining the motor, but when you're done, now that all the head screws loose, you can pull them out. Now with the liner and sleeve and head out, and the piston at top dead center. Remember, the rod will only go in one way, and the way you tell which way the rod goes in, the part that faces in the exhaust port, the closed part, the part that's closed, faces the back of the motor. Now if you look at the way the piston goes in, each side of the connecting rod is a little bit different. that side is open. You don't want this part in the exhaust port. You want the closed part in the exhaust port, so that would tell you which way this assembly is going to go back in. So, very carefully now, you want to look over the case. Make sure you don't have any goop in there. Get rid of as much of this as we can. Clean it up. The collet on the front is a press-on, and if you can get that off by hand, usually you can just wiggle it off. And that releases the crankshaft, and this is now the old crankshaft. I like to look inside because we do have extra bearings if we need them, and make sure nothing in there is grinding or not nice and smooth. The bearing looks like it's almost brand new. You almost never wear the front bearing out. It's the back one that would wear out. And I'm just feeling around in there for any burrs or any loose material that's in there. It looks like it's perfectly clean. See where the difference in the weight comes from. They run the milling machine across the back of it, removing some of this material. And that's where the gain is. And I believe, I've got to talk to Richard again, that the timing is slightly more robust, but it may not be. This looks very similar, the crank time, but it could be that it's moved just a little bit. But anyway, we're going to obviously save the old crank. We have a Rojett box with all our parts in, and now it'll be a very simple thing to install the crank. And this is the new lightweight 65 crank. Now, since we already have plenty of motor run after run motor oil in here, this should just be a drop-in fit. With a sleeve, it'll just be a press fit until we actually put the thrust cone on. And the crankshaft, the new crankshaft is now in place. Reinstalls, you have to be sure that the rod is all the way on the outside. Otherwise, it's never going to catch on the crankshaft pin. So I just kind of slide that over, try to keep it there. Now, a lot of times you can just very carefully line this up. There we go. We've got the rod. That can be a little frustrating sometimes. Make sure that piece is in the back, the sealed side of the rod. Make sure everything's running free and clear. As you slide this in, of course, the exhaust port would go to the back, or if it were a side exhaust engine, I always make sure I put a little bit of fuel on it, a little bit of oil, make sure it's got a nice tight fit, and of course these are nice tight engines. Now, most important thing is, we want to make sure we have the exhaust port exactly lined up. I don't want to have it that the liner is in crooked one way or another. If you're ever in doubt, the way you can double check your work is put the piston all the way up, and the first port that opens better be the exhaust port. In this case, we can see, because we definitely have burn marks and everything here that we can use as a key to lining it up. Comes in real handy is one of these guys. That's what I want to do with the head. I've taken out the gasket. I want to make sure it's perfectly clean before I assemble this. And if you wanted to, you could at this time take some of the bake castor oil off. Right now, I don't think we're going to be too worried about that. And just for reference, if you were really thinking about it, or you really wanted to know, there was a little mark, and it's right there, that helps line up the exhaust port. But basically, you could look in the exhaust port and see if it's lined up. Now, when we reassemble the head, there's a little scratch in the front. This denotes the front of the head, even though I know you could put it on some other way. And now we want to, one by one, very, very carefully, and little by little, reverse the procedure for putting in the head bolts. I want to tighten each one, and more than anything else, I want to go opposite, opposite, just hand tight, opposite.
not to tighten one bolt and leave one loose. I can't even tell you how many people have come to the shop, say, oh, this engine or that engine doesn't run right. And when I've retorqued the head screws, it's run fine. And what would typically happen, you might have a tiniest leak at the head, but it makes the needle settings erratic. Because not only are you blowing things out on the exhaust part, the compression part, but you're sucking in air, which makes for some pretty erratic needle settings. Now I've just got these all just hand tight. And I'm trying to do this by hand. We'll ultimately do a final tightening with Russ's torque wrench. Okay, now you can see I've got the 4 opposite ones. Now I'm going to do the same, basically the same thing with these. And within the next couple of days, we have a big party to go to tomorrow, so we're not going to fly tomorrow, but again, I just want it hand tight. In automotive technology, they call this tightening the head like a star pattern. And now from this point on, I'll just take each one in just the slightest bit. So I'll go maybe 1/8 of a turn, 1/8 of a turn, 1/8 of a turn, 1/8 of a turn. Now Richard at the team trials told me the head gaskets only go in one way, since we don't have a head gasket in now, and we've run pretty much all the motors that we've gotten over the years with no head gasket. The machining tolerances are so close, I don't think you really need the gasket. And that one was a little looser than most. That one was a little looser. A lot of times you can look and see the head's not going on nice and straight. But this just takes a little bit of extra time to sock it down equally. Well worth the time. Now we'll torque each one of the head screws down and the back plate screws at the end with the setting, which is 14 to 16 pounds on the torque wrench. And of course the final thing, I always put a couple of drops of fuel in there to let it walk around before I have to run oil, but since we're going to start the motor, fuel is an appropriate choice. Make sure that lip is up. Make sure there's plenty of oil or fuel in there. Piston has to be all the way up. We can line up and torque these screws down now. It's a traditional Venturi, and here's how big this spigot Venturi is. Just for a point of reference, you see how much larger it is. The swept area is not enough larger, and this Venturi for sure is going to need pipe pressure. I've already got pipe fittings installed in all the pipes for our test sessions. And it's this time of the year that you can do these experimental things. If we were in the middle of the contest season, I wouldn't bother, but these are just things I wanted to try. Again, this is something George Aldrich made me, and I think it's worth giving it a try, just for our own information. A bag with all the parts that are coming out of this, including what is the head gasket that came out of here, the Venturi that came out, and the old crankshaft. So these will be in a little package. They'll be all our original parts. If we decide we wanted if we had nose weight in the plane, well, why not use the heavier crankshaft? I mean, there's a lot of choices here, but having all the original parts the day we go down to the field will be a big help, and we can of course just swap them out as necessary. It's always nice if you have this kind of a little socket, but not to have to use pliers on these delicate brass parts. The tolerances are very tight, and you don't want to, hopefully, in fact this one is very tight, so we'll just back it out rather than drag the threads through the nylon. You don't want to damage those threads at all. Now, real important whenever you change a venturi, where the hole is, I put a little scratch. You can see the scratch right there. So that when I line this up, I don't have the hole at the back or facing down. I have it in the same spot, basically facing forward each time. Just to compare how much different the size hole is. Again, it's only an experiment anyway, and this is one that George Rojett had made with a little piece of brass tubing. Here's a little bit of a lip on this that confines it in place. And it's just a question of making sure we have a nice through piece on the case and reinstalling the needle valve. You can see where I want that facing directly into what amounts to be the feed hole for the fuel inlet. The last thing, the little cinch nut. Making sure that when you've tightened this, that little piece is still facing forward. Now these are some 1/4-28 threaded aluminum rods. Now, if you're looking to get all the weight out, of course, this is a significant piece. You can use the aluminum. The problem is you want to really be careful you don't strip it by over-tightening the nuts. And with these, Bob Zambelli made up some nice aluminum nuts and a couple of spares. So when we go, and we'll do it later this week, we're going to set up the plane. What we're going to do is, this will be ready. We have to do the header part. We need the lightweight thrust cone. We got all the lightweight parts on this. Once it's done, I guess it's a good idea to just get all the residual oil off it. And we're prepped for the next session where we're actually going to put it in a plane. Try it, see which ones of the parts are going to work for us, which ones aren't. And I hope there's some good useful information in this. Something you can use in the future, especially if you're using a jet motor or one of the other modern motors that are very similar in construction and metallurgy. These are really the Rolex watches of the industry. The box that Les and I put together for all our typical Rojett stuff. And what I'm going to do, I'm going to make one of the little compartments, all the original parts that'll go back in here. In fact, I can take some of these screws out. We'll get enough screws to choke a horse here. And this can be all, well, we're going to need a bigger spot. You know, the crank fits in there. That's all the original stuff. Well, Les did a nice job of organizing this. We have our, needless to say, our bag of Venturis and our bag of test props and our torque wrench. And the last thing I'll do today, in fact I better not forget to do it, is take out the torque wrench. We've shown this enough times on video. I don't want to forget to torque all those screws down before we actually run the motor. This thing, of course, is, since we're going to do this in the next day or so, I won't bother plugging it back up. I put a little bit more of after-run oil in here. Put it in a sealed bag and we'll be ready for our retrofit. We have our pressure fitting. These sandwich bags seem to contain it real well. And in the next couple of days, if we get this installed, we have some props to make up. We have some other stuff to do. I hope this is good information, and I hope you can use it, and I hope you enjoyed seeing how a crankshaft goes into a Rojett. Well, this morning I got down and I wanted to retrofit this, get all the stuff in here as soon as possible. Later this week we're supposed to have some flying weather, but we have had 6 days in a row of unflyable weather. So I thought, one of the things I wanted to mention, I wanted to get this whole package out of here. This whole package, prop, tank, engine, venturi, pipe, coupler, everything, and that whole thing becomes the nucleus of Les's new 60 ship. And he's already planned a 60 ship, 65 ship, 61 ship, whatever you want to.
and also a 40 ship, but that whole powertrain now has been proven. I thought it did pretty well at the team trials, and we won the last local contest against Danny and Suarez, so we really want to save that just the way it is and retrofit all of the stuff, the engine with the new crank, the spare pipe, and make another prop up and make a whole new powertrain. So this now is Les's 61 and all his hardware. We'll put that all in a big plastic bag and it'll be ready for him when he's ready to fit that into his new plane. Yeah, this will be such a big help to Les, having this whole thing ready to go. Now, some of the things that are significant here, we had a 210 Venturi. This is a 61 bar stock. This was our final setup. We have the prop pitched to a gauge that both Kent, Midgley, and myself, we all have the same gauge. And I'll pitch up another brand new prop for this. We have all the head shims out of the engine, a Thunderbolt RC plug, volt and half RC plug, pipe length from the glow plug to the first baffle on this pipe, 17 5/8, seemed to be good for Muncie. But I want to leave this, and the only real problem we had with this motor, that was a constant problem, are these cheesy Home Depot zip ties. Well, we now have better quality zip ties, and you can see what we were doing was putting 2 on because they were failing on a pretty regular basis. So my suggestion is buy some good quality zip ties. We got these some from Kent Tyser and some from Warren Walker, and we're going to use those when we set up the 65 with the light crank in the plane right now. Another thing, whenever I do this kind of a pull the whole plane apart and put it back together, there's a lot of things I like to check. I like to clean the filter. I like to check all the tubing for pinholes. Check the tank, give it a pressure test. Check the prop for balance, but in this case we're going to make a brand new prop. And most of all, look around, and in the case of this, we've got some spots where the paint is wearing thin after 2.5 years. Look around at the hinge line tape, that it isn't getting a little ratty. Anything else, the wheels on this look pretty well worn out. I'm sure we're not going to get the rest of the season out of those wheels. What happens, they wear on about a 40-degree angle, and then you can reverse them and get another month out of them, but eventually you just have to buy new. These foam wheels just seem to self-destruct very quickly. Anyway, a lot of little maintenance we can do. Check that all the cowl mounts, that they aren't getting loose or broken. We have had a problem with the front cowl mount on this has been broken and fixed with JB Weld. And basically, I think that the way the team trials went, it benefited Les having that whole motor, and now we can spend the rest of the season experimenting with our 65. There'll never be another contest that we have to use a 61 in, so we can move right along. And in my feeling is the 65 is a little bit friendlier and suits my needs a little bit better. Because we're going to be running pipe pressure with this big Venturi setup, this is the pipe that I had to install a pressure fitting on, and I need to make sure I've already pressure checked the tank, make sure that the tank doesn't even have the tiniest pinhole. Now, even if the tank had a tiny pinhole and you were running suction, not much bad would happen. Maybe some fuel would get in the plane. But with pipe pressure, the tank must be sealed. That's a really important part of keeping it sealed, and we're going to run a fuel filter up here to make sure any loose particles in here or any dirt that comes through this line doesn't wind up back in our fuel tank. Now you can see the difference in size, and boy, these are really strong. They're rated at I think 280 or 300 pounds. These other ones are rated at 18. And I think the difference is the material. You can even see this material is shiny, this is dull. This is a special material that's good for very high temperatures, I think up to 300 degrees, but I'm not sure. I gotta look at the spec sheet. In fact, here's the spec sheet. Let's see what this is. This is from Warren Walker. Does it tell you anything? Anyway, these came from Warren Walker, and we're going to be testing them, among other things that we're testing here all at the same time. Just having a better zip tie, and I'm sure that when you take 2 of these and weigh them against one real one, see, these have steel teeth and these have plastic.
So I think that's going to add a little bit of reliability. Also, when we're running pressure, we don't want to have any leaks. This will be a little bit of a, maybe keep a test to see if it's going to keep any of these joints leak-free. What would happen here is this would break, and nothing bad would happen, except this would start leaking oil back, and you just make a mess out of the plane, which should stay relatively, well, relative is a big word, relatively clean during the whole day of flying that you're having. Anyway, we're going to try the zip ties, and we'll certainly report back how they worked. On this project is we're going to make us a new replacement prop. Now, it took us an awful lot of time to get the pitch just right to where we were happy with it, and we've changed our gauge about 35 times already. But we know now that the 61, when it was relatively new, wasn't happy turning a 13-inch prop, but after it had 7 gallons through it, it turns it just like the 65 does. So what we start with, and in this case I'll just go through step by step real quick, start with a prop from Randy Smith, a standard Bolly. They come 13 inches by 4.5. It's a standard prop. First thing before we do anything is we want to balance it. A balancer that we use, a wheel balancer, and I found these to be real easy to use. Sometimes they come relatively closely balanced, sometimes can make you crazy. You never know. So that's our first heavy blade. We want to figure out which is the light blade. This is the heaviest blade we have. These two are the heavy blades, so we're going to take some material. The 2 blades that fall down first, we'll take a little bit of material off with a sanding block. We'll try to take as much of it off the back as we possibly can, and as little off the front if possible. Which one you pick, you just want to make sure. We know we have 2 heavy, which is always the case. You always have 2 heavy blades and 1 light blade, or else it would be balanced when you get it. So we're pretty sure in these 2 blades, this is the most heavy of all of them. For sure, this is the heavy one. So I want to take a sanding block and see as much of this. By the way, what I did off camera, I trimmed off the blade lengths to make sure they're equal. Again, I like to wear gloves, and I like to, if I'm not doing this on video, I'd be doing it either outside or over the sanding bench. Right now I have a lot of work sitting over there. I didn't realize I was going to be doing this today. Another poor planning episode. But now we know, one, this is still going to be heavier, but let's see by how much. Okay, so we know this is still the heaviest blade, but we're just going to keep hammering on it. You want to get as much of it off the back as possible. Now you might be asking, why don't you pitch it first? Well, the trouble is when you do this sanding, a lot of times you, without wanting to, incrementally change the pitch. And it looks like this one is going to be one that needs a little bit extra work. Again, you just got to do this step over and over until we have, now okay, we've got it almost, that's an almost. This is certainly heavier than this blade, so this becomes the light blade. Still the heaviest blade. So without further ado, you can just keep grinding away at it. And if we can't get enough, we'll take some off the front face. But I'd really like to get as much off the back face. And you want to get the material as far out at the tip as possible. And this just takes time. Now we know they're not equal yet. We know the 2 heavy blades are the same. Now we know this is the heavier of the 2. still heavy. Whichever blade falls down is always going to be the heavier one. Now, of the two we worked on, now this is the heavier. Not by much, though. Again, if you just keep incrementally sanding the blade that falls down, you'll eventually get it to where it'll stop in any of 3 or 4 or 5 positions. It should stop no matter where we put this, it should stop. And still, that's the heavy blade. So we just have to keep working this blade. And this is 80 grit paper on a sanding block. Get the dust off. See, these are the 2 blades we worked on. We know we have, this is the lightest blade there is, and we've made these 2 equal. Now we want to make these 2 equal. And you can see this one is still a little bit heavy. Just keep taking material off the blade that falls down. And try to take as little off. Now, we haven't taken anything off of that blade. If we go too far, then we have to take a little bit off of this. Now, we have the 2 lightest blades, the 2 that were heavy, at least the same. We don't know if they're both the same as the light blade. And in this case, where they are, we have a light blade and a blade we worked on. Now we can use fine sandpaper from this point on. Just a tad, I'd say 1 swipe. And we've got it balanced. And when it's balanced, the test is it would stay in every position. No matter where we put this. In all 3 stations. See how the tricks you? This one is still just a tad. And we'll just now with fine sandpaper, because we're getting close, we'll put some 220, some fine paper, and just get this finalized. And when it sits in every position without any blade falling, the balancing is done. Gauge that we have for the 65 jets, the 13-inch 3 blades. Again, you can see that we've changed this pitch angle incrementally 1,000,000 times until we have it just right for what we want. Now, if I look real close at the pitch, in other words, if you look down here, we don't, let me do this. I'll try to get it that you can't. We don't want to be able to see light under the front, we don't want to see light under the back. We want to see a flat edge. Now what I do if the front end is up, I want to dip it in boiling water, 5 seconds, and just tweak it just a little bit. That one's real close. You have to check every blade. Well, it looks like it's real close. You can do it with a heat gun, you can do it with boiling water. Now, one of the last things, I like to etch the hub. Both sides. So when this gets a grip, it's good and solid. It isn't a slippery surface. Real inexpensive. They're about $9 in Staples and engraving tools. Everything that you're tightening the prop nut on should always have a knurl or a rough surface. Very, very important. Often overlooked. Now what I also like to do is write the year. For my own reference. Having that surface roughed up, whether you do it with a Dremel tool or razor blade or whatever, very important. And that's a prop now. Now we have an exact copy. If you have a brand new motor, I would suggest you get two props. Cut a 1/4 inch off each blade so you have a 12.5. A motor at less than 5 gallons of fuel through it, 12.5. Once it has that fuel through it, and it's nice and loose and free fitting, I think you can spin the full 13-inch prop. Happens every time we pitch a prop, every time we change a prop, every time we make a gauge or adjust a gauge. We've added to our database. And for anybody that would like us to pitch a prop for them or do a prop, contact me, let me know. Or if you'd like to, I think it's easier just to watch the prop video. It goes into detail about more of this technology. And very easy to do. I don't think it's out of the realm of anybody to do their own props and understand what they're doing when they pitch up, pitch down, change diameter, change prop load. I think it's pretty well covered on the prop video. Now the only thing to wait for, to test our new 65 setup with the pressure. Boy, we just need some weather. And boy, with all the rain, I'm telling you, this has been really disappointing. We're sitting here on pins and needles wanting to go flying. Yeah, believe it or not, I wish I wasn't telling everybody this. We're expecting a hurricane. I mean, I moved to Jersey from Florida because I hated hurricanes. I'm really from Pensacola, Florida. Of course, I moved when I was 5 years old, so that's beside the point. But I wanted to go through something, and I thought this would be helpful information, useful information, because it's been probably 9 months, maybe even longer, since we worked on the A26. We've had a very busy summer, but we want to start laying out and making some of the parts while we're doing other things in the shop. And as long as we're going to suffer through a hurricane, we may as well put a little time into the A26, a little shop time. Now, our primary goal in building the A26 is to make a plane that's possibly a little lighter, a little better aerodynamically, but certainly not a whole lot different. And I want to explain in a little storyboard what I think some of the things that we may be able to accomplish, hopefully, with the time and effort that we've already put into this project and the time and effort that we will be in the years to come. And I say years because this is a project that I want to make the bar higher than the B25, or there wouldn't be much point in building it. Now, when Dave Downey did the original concept drawings for the B25, I laid them out on the table and I was just awestruck. I don't even know the right word. I was so impressed with the look, the side view. In fact, even if you go back to those old videos, you can probably see that Joe Adamusco was holding up the paper on the side of my car. I walked 70 foot away and I looked at the profile and I said, God, I just knew at that point in time I had to have one. Well, I've always liked the A26 also because it has a really nice profile view. But one of the things we're going to try to do is incorporate, what we've already done, and we've done it twice already, we actually have 3 wings. One is totally finished, glassed and everything. Mike Costello has that one. We have one that we're going to do for our project that's just going to be joined, tips, and a bell crank in, possibly in the near future. That's one of our projects. That's been sitting over on the table with all those Strega top blocks, and we've been making one a day for those. They're just coming out like cookies out of a cookie cutter. But we want to try to really use all the information we can from this, and I think these are the significant things we've learned.
that we can use these power plants, these props, these carbon tanks, these cowls, and we'll just have to redraw, and Les is in the middle of doing that. He's really done a detailed job of it too, making plans for the nacelles. I'm going to try in the near future, hopefully one of the next days that we have a whole day to work, is to frame up, do the drawings and frame up the stab and elevator, but they'll be very close to being the size, shape, thickness, and the construction techniques of the B-25. So we know if we have relatively the same wing, we know that wing easily handles 80 ounces. And we know that tail, when we built it, was, I have to look at the notes, but it was probably in the neighborhood of 3.5 to 4 ounces. And we know the heaviest part of this whole plane, I think one of the areas we can really improve on, is the fuselage. The fuselage was all built up. It's full of formers and blocks and screws, and I think by making a mold, a plug for a carbon fiber fuselage, I can really cut some weight out of that. And some of our Strega top blocks that we're making, but I think one of the things we'll be able to do with this whole project is we'll be able to make the model a percentage lighter. I don't know how much. Certainly, but at the end of the last 2 flying seasons, we've got it to where it's a little under 80 ounces. And except if you're going to fly in hurricane winds, and I'm not so sure that that's well, 7 of the people didn't fly at all, so I don't know, and they were single-engine planes, so I don't know. It's hard to evaluate something like that. But anyway, I really am looking forward to, for a lot of reasons, is if I have, my other motive is if I have a plug for the fuselage when I make the A26 from Les's plans, in essence what I'll have is an ability to supply people with a carbon fiber shell and a foam wing sheeted, and on an A26 there's only one dihedral brake, so it would be a much, much easier plane to build. And if it's take-apart construction, and I think we're going to basically copy the way we took this apart and just change the cosmetic outlines to being an A26. But what we're going to do is, instead of shooting for 80 ounces, we're going to hopefully come in some percentage less. Somewhere between 75 and 80 would be nice. I know every time we took even a ½ ounce out of this plane, performance got better. But we don't want to change. There's things we want to change, but there's things we don't want to change at all. The moment arms, the aerodynamic relationship between the wing and tail, the heights, all that worked, I thought, just super. I thought, in fact, we don't even need adjustable readouts because we know exactly where the readouts go. And hopefully that'll just make the building of the plane a lot simpler. Again, I won't know till it's done. We've had a wonderful season. We had a great team trials with Miss Ashley. Now got the 65 back in it. All the AMA, motors, tanks, whatever, parts, props. But the real love of my life, of course, is the B-25. This is what I live for, the days of getting out to the field with Rich Jacobone and getting fresh batteries in his e-tron and just flying this guy and wearing the wheels out, which we've done plenty of. And as much fun as it's always been flying single-engine planes, and as much of a challenge as it's always been, I don't know, it's just not the same as flying the B-25. There's something about going even to the field. On the way to the field, you go through a different set of emotions. So really looking forward to the A26 project and whatever I can do to move that along during our lovely hurricane. But I just want to share the basic concept of what we're trying to do and how we're going to try to do it.
I think what's real attractive about it, the A26 has a really nice side profile view, the view you see from inside the circle. And I've even looked at Les's preliminary drawings, which we've shown on a video already, and we go out to the garage and put a couple of pieces of duct tape holding them up on the garage, move 70 feet away, and just picture that in a square loop. I'm not sure that won't look real cool in a square loop. parts, and because we're in the middle of a hurricane season here, I don't even know how to describe this. One of the parts we're going to need, or a small part we can make, even though we're still in the flying season, we can make little pieces and parts that when we actually come to the construction part of the year, we have these parts already molded and made. One of them is, you can see what I've got from the year before. We have extra pieces, and this was parts that were molded, and I wanted to show this. These are the leading and trailing edges for stabs and elevators. One of the things that happens, though, is when they sit over the winter, you pretty much can see what happens. They go back to their old shape because they're not held in the shape we want to have them in. So what I wanted to do is I take these old pieces out, just clean the dust off of them, and there's several ways of doing this. What I did here, I mixed up Windex, half Windex and half ammonia, straight ammonia. And I'm just going to wet these parts back out. And in essence, put them back in a mold and remold them. And I'll make a whole bunch of them. Now, I always have extras. And it's always a good idea, before we even make the drawing for the stab and elevators, we can make the molded parts, because we're going to need several. If you need one for the leading edge, one for the trailing edge, well, why not make 5 or 6? Then you can also take the lightest one. You can also take the one that comes out of the mold the straightest. In this case, you can see this one has a crack in it, but up here I've got enough of a piece that I can do a leading edge. Well, that's why I need a 12-inch piece for a leading edge. Well, I've got it. So there's no point throwing this away. This will make a good part. I just won't be able to use the whole piece. But what I'll do now is every chance I get, I'll put another piece in a mold. And this is kind of a neat little mold that I have. It's made out of balsa wood. It's like a guillotine. And you pretty much have a dowel that's just scotch taped and Tefloned onto the front piece. And you put the piece that you're using in there and kind of guillotine it in, I guess, is the best way. But anyway, once it's in there, you would assume anyway, in fact, we're going to have to, because of the way, there we go, because the wood is wet, it's a little bit oversized. You just put it in there, and that molds it up. Now, the alternative way of doing it, let me take this apart, show the alternative way, would be get an ace bandage, the same as we mold our other parts. This one's split, so it's good that we're done with it. Another way you could do this if you wanted to, you don't want to make one of these molds, one of these reverse a guillotine. You take some of this wood, get it good and wet, and if you can let it sit under water for a half an hour or so, put it in a bathtub or whatever, a little bit of ammonia, water, Windex, all will make it soft. You could really take this piece and just put your ace bandage around it, and that would make for a nice piece also. But no matter how you do it, the idea is, at this point, the idea is to get parts, like I always call it making a kit. Little things you can get made up ahead of time, that when it actually comes the day that we want to build a tail, and let's say it's a rainy day, it's a rainy Saturday, you get up, you have your coffee, you want to, well, not the first thing, you mold up the leading edge and you're done for the day. Well, wouldn't it be nice if we had a whole bunch of leading edges already molded up? So what I'm going to do in the next couple of days, and I'll do most of it off camera, I want to get a nice supply of molded leading edges. Now, even though we could probably use these, it's just, in my case, it's just easier to make a few new parts. And if I can salvage some of these, even though they have splits in them, if I can salvage some, even better. This one I guess I can't salvage, it's split all the way. But you're always looking for some nice A-grain wood that has a nice straight grain in it. Get it good and wet. In this case, this one looks to be the best of the batch. Molten balsa wood. We've got, I guess since 95 or 96, every plane we've had has had a tail. Spitfires did, the Typhoon does. They're flat tails, very similar to what an Impact uses, or an original sweeper if you go back that far. Ooh, this ammonia is nice. You want to get high, just breathe ammonia from a sprayer. This one looks like it'll be the best one here. But again, if you just let it sit, the longer you let it sit, if you can do it with hot water, really hot water, it'll just turn into butter and you'll have yourself a nice leading edge. Whether you do it with an ace bandage, you actually can do it. You see how nice that can form? You can wrap it with a bed sheet a la Al Rabe. You can wrap it with a piece of towel. But an ace bandage is really the easiest way to make that conform exactly the way we make the top blocks for the planes.
Just to show you how old this technology is, this was published in 1968. American Aircraft Modeler. And this plane was the first one I had that had a flat tail, where all the ribs were flat. And I thought at the time, I had copied that from somebody else, so that technology is obviously built. I don't even remember who I copied it from. The technology has been around for an awful long time. It's on Paul Walker's impact. He clearly used that when he designed the impact as one of the key features, and many people, including Dave Fitzgerald, myself, I guess Randy Smith, I'm not sure. So many people use it that it's pointless to even argue it. It's a technology, it works. It allows you to line up the tail nice and easy.
Really sure whether Al's planes have airfoil tails or flat, but from the picture here, I actually got to see this plane at the Nats. Didn't notice if it had a flat tail because I had so many nice details. I was just oogling and ogling over the details.
Typhoon had a flat tail. Again, all these flat tails have been built on video. They're all available as copies of older videos. But it's technology that works, and it makes building a plane a lot easier.
I remember at the team trials talking to Dave Fitzgerald about the tail, and he was I think it was this model here, I'm not sure. His planes kind of look similar. But he had used a flat tail and a lot of slop in the controls, and he had taken the season and taken a slop out of the controls, flew the plane for a whole season, was unhappy, put the slop back in, the plane flew great. That obviously flew good enough that he won this year's Nats, and I think had he not had a fly in the rain at the team trials, he might have done better, but that's all literally water under the bridge right now. The point is, flat tail technology is not new. It's not something you should be afraid of. It'll work for everybody.
In the really olden days, when Harold Price used to show me little tricks and tips and help me build planes, all these planes here had, the blue one that you see had a half-inch built-up tail, I remember that. And this one had a flat piece of quarter-inch tail, and this was, because it was thicker and it was more rigid, seemed to be a better choice. So it was basically from this point in my career on, this was a plane of his that I refinished as a junior. Imagine this, we're going back to the 60s here. What this was all about was people realized having a stiff tail was an advantage, and of course having it as light as possible another advantage. But because Harold had built several of these that were very similar, he could pick out the details from each one. And his later models, the Crusader, the latest one, evolved into what I thought was one of the world-class planes of all time. But it's that constant evolution that makes planes get better and better and better.
The three Spitfires that I have, only one has a sheet tail. This is a quarter-inch sheet tail I tried to replicate from the Valkyrie days. But looking back, I think the other two with the half-inch tail flew a little bit better. Not sure. I've heard several reasons why, because of the tail displacement being less. It's the displacement that counts, or should count, or does count. I'm not sure. But I know from having built them both ways, I know the better way, or the way that I will be building planes in the future, when they're wood planes, will be a half-inch flat tail. And here's some of the advantages of building that way. Just here's some of the advantages that I find from the way we build planes, the way we use flat tails. You can always use a reference line. It's called a datum line, from which all of the things are measured. In this case, that would be the datum line. That would mean that the motor would be mounted and would be in parallel alignment. It would also mean that the center line of your wing, when you measured up from here to here and here to here, these would be equal. But also, if you're going to notch for the tail, and if you look at several different designs, some use a lower tail, some a little higher, but you can always use this parallel line. And when it's a flat tail, pretty much the stab will sit in here. Just to make it very simple, the elevators would have some taper. It's almost a self-aligning feature. And I think that's why a lot of planes with flat tails seem to fly better than, or as good as, planes that have more of an airfoil. When you have an airfoil,
Again, like in the old days of doing foam planes, if you tried to set it here, you really had to set it half in and half out. Or if you lowered this and you put a notch, you had to set the tail in on a center line. This really got awkward, and really getting it so that the elevators were neutral at the same time, you can see where that could be pretty involved. And I think that's one of the reasons a lot of planes that don't have flat tails may not fly as well as some of the ones that do have flat tails. Just maybe, but this is definitely a lot more work. To get this alignment, whether it's the fuselage top or a center line here, this is still something you have to deal with. I guess going back as far as you can go, almost everybody used old Barnstormers, a flat tail, most likely a 1/4 inch or 3/16, just a flat piece of balsa wood. A Vico Chief would be an example. But that evolved into what I thought George Aldrich keyed into something, that the Nobler had a kind of an airfoil tail, the planes from the Nobler era, and it was typically a little bit thicker, 3/8 to a 1/2 inch, had ribs, had an airfoil in it, either was tissued or sheeted. I guess the Nobler would be the way to describe that. Now, advantages and disadvantages. More rigid. Definitely this would be more rigid, but harder to build, harder to align. So a lot of guys years ago, when they built a Nobler, would just use a flat tail. A lot of Gene Schaefer's planes had a flat tail. They flew fine. And a lot of guys keyed into the fact that having an airfoil in the tail was a lot of work and not a big advantage. It didn't represent much of an advantage anyway, if it was. And they were much happier using that method. On several of Bob Barron's designs, he would have, I think the Avanti is one of them, he would have the tail be 1/2 inch or 3/8, and the elevators thinner. So there'd be a little dead air spot where the elevators would operate in dead air. Well, that had some advantages and some disadvantages, and several people, I for one, tried that several times and never found that dead air to be as effective as slop in the controls. Now, fast forward into the 90s and into modern planes, well, and we'll use an Impact for an example, 1/2 inch, fully tapered elevators. Now, I've heard Paul Walker has no slop in his plane. Dave Fitzgerald does. Both of these people are very successful flyers, so I guess it's pick 'em. But again, with a 1/2 inch tail, you have some dead air. So even when you say you have no slop in the system, a 1/2 inch tail really has some slop. Before that elevator comes up and changes the flow of air, you still have a little bit of a dead zone. It's just less than if you have slop. And any combination of, I guess you could use any combination of slop combined with this to suit your own needs. But the best of all worlds, there's, for lack of a better word, the best of all worlds would be to have a 1/2 inch stab, 1/2 inch elevators, and a pull pin where you could remove the elevators. And then you could make, if you were really interested in finding out the truth of life in general, you could take the pin out and put 1/2 inch elevators in, take the pin out, put 1/4 inch elevators in, put thinner elevators or thicker elevators on the same stab, and even better than that, if you want to go the whole way on your control system, have adjustable slop. And or an adjustable push rod, whether you do it with a joint or a Bill Biles connector, no matter how you do it, having all the choices. Now, one of the reasons I think Dave Fitzgerald's plane flies as good as it does, and I think it's one of the premier planes around, he has tried all of these options, made different tails, tried slop, no slop. He's done all of the testing and found out what suits him the best. And by doing that, it's taken years. He's got his planes evolved into really, really world-class airplanes. Case in point, he won the Nats. I thought he flew very well at the team trials. Read him and weep when it comes to competition, but a good flying plane is still a good flying plane. So this pretty much gives you all the choices. Now what I like, and what I'll be doing, and the B-25 as an example, is exactly that. I have the tail, I have the elevators. It also allows me to do another thing. If I have a pin that I can pull the elevators off, I can try bigger or smaller elevators. I'm not married to one design. Or if the elevators come out heavy, I can try lighter and heavier elevators. I also, because it's a take-apart plane, I can unbolt the stab, like any take-apart plane, take out a few screws, and put the whole tail in, a whole lighter tail. A lot of choices. You want to think this through before you put 200 to 300 hours into a building project, and to give yourself as many choices as possible. And I think what we've evolved into is a tail that comes off so we can replace the whole tail, or a tail that can stay and we can replace the elevators, or that we can replace the slop and we can adjust the push rod length. In our case, we have a slip joint, but you could use that, like I said, and I may try one next season, one of the Bill Biles connectors, just so I have another adjustment in there. In this case, you really do have a unique amount of trim features all built into one package, and you should be able to, in this case, even as time goes by, fine-tune and make the most out of all those hours you put into a building project. We've had this on the video before, but we may try one of these next year, because we'd like to have even more trim features. I'm always looking for more ways to trim. And Bill's used these and sold these for years. Here's his phone number, 909-318-2580, and each one weighs 4 grams. That's not going to ruin any plane. If you don't have a plane that will carry 4 grams around, you need to make the wing bigger. Anyway, I'm hoping this is useful information, and when we actually do start cutting wood for the tail, we'll be ready to make as many choices as possible. And that seems to be the secret, is to have a plane that lasts a long time, and every time you fly it, you can get more and more trim on it. And eventually, as the planes get older, they just seem to fly better and better and better. One of the things I think, and I'm pretty sure that I'm right, one of the things I've been able to help a lot of people with, they all seem to fit into the category of, gee whiz, I don't have enough time to build. Well, one of the reasons that they don't have enough time is the time management, allocating time. Now, just as an example I just gave of, you wait for the day you're going to build a tail and then mold the leading edge, that day's shot. You're done, because you got to have that part to start. So what you want to do, maybe, and we're about maybe 2 or 3 weeks from the actual end of the flying season. I think there's one more contest left, but I'm not sure. And the way these hurricanes and rain and everything is ruined this season, I'm really looking forward to the building season a lot more than the flying season. The rest is too, and we're really planning to do a lot of things over this winter. We're going to have a very busy shop season. But time management, making sure you get the most out of every hour that you spend. One of the things I've done in the past, and I'm going to do it this year, is this is what I call make kits. Let's say, for instance, you decide you're going to build a plane, and it's going to be a Nobler, for instance. Well, you're going to build it from scratch, so before the season even starts, you want to get the wood. Order the wood, or buy the kit in that case. Get the glue. You know you're going to need a gallon or 2 of dope. Get the finish, or the monocoat. Get the tank. You know you're going to need the tank to build the nose, to get it right. The motor. Get all these supplies on hand. Now, by doing all this, just as an example, and there's more, of course, the silk span, the bolts, the whatever, the control system, but get it ready, in essence, the bottom line, make a kit. So before the building season even starts, kind of build a plane in your mind and say, yeah, I need 10 pieces of wood, I need 3 things of glue, I need a gallon. Have all these things in the shop on hand ready before you ever even clean off the workbench. How many guys I've known They wait till the day they're going to start building, go over to the wood rack and see they don't have enough 16ths to build to cut out the ribs. Well, getting this ready while you're still in the flying season is a big help. Make a kit. That's been some technology that served me well. Another thing, and a lot of people laugh at this, I tell them this, and they go, oh man, that's out of control, that's crazy. What you do is I do anyway, I buy time. And that means that a calendar day, let's make a typical calendar week up, and everybody has what I call chores they have to do. Well, in my case, here's what I'd like to do. I'd like to be able to fly Saturday and I'd like to fly Sunday. I'd like to have those days as free as possible. So what that means is I try to pick a day here, and this would be a typical day, mow the grass. I try to get Karen involved in this, and so we have a shopping day. Or if we decide we're going to have company, whatever each person is going to have a different set of things. In this case, we usually spend at least 2 of these nights either visiting the kids or having them visit us. So I don't want my building or flying to interfere with that time. So what I look, though, is I try not to plan things. I'm going to back this up just a minute. We just had the battery go dead. But what I'm saying is when you want to fly on a weekend, here's what I've seen other guys do. They wait until Saturday morning to mow the grass. Then they decide Saturday afternoon they're going to do their food shopping. And that, something that if you try to condense all your obligations or things that you can control the time, and you leave yourself some time on a weekend, free time for building, shop time, or flying, you can manage the time. An example is, when I go outside on a day, and let's say it's any day during the week, and it looks way too windy to fly, or it looks like it's going to rain, I try to think, can I get the grass mowed? Can I do my house cleaning? Can I wash the cars? Can I do some of my visiting, or maybe I want to have one of my friends over for lunch? I try to get things on rainy days done, so that when the weekend comes, if it's a nice day, there's nothing worse in the whole world than it's a beautiful Saturday morning, you get up, and you haven't done your shopping, haven't mowed the grass, somebody comes over to see you that you could perfectly well see on a rainy day. But keeping those days that you choose for shop days or for flying days open for your own time. I call it buying time. It's probably not the right way, but managing the time. And I've been able to really help people see a different way of managing their time and getting a lot more quality modeling time done in the same amount of time. A lot of people tell me, it took me 2 years to build an oval. Well, it really didn't take you 2 years. It took you 2 years because Saturday you had company, Sunday you mowed the grass or whatever, or shoveled snow or whatever, and you never really figured out where that time went. One of the other things I do, and maybe not apparent from the video because you can't see a clock in the background, but a lot of times when I have a project I'm really working on, I get up early, Karen will go to bed, I'll come back down the shop, and I'll work another hour. What happens, what I call them early and late hours, the phone doesn't ring. You don't have people coming over to see you. You don't have the local neighbor's kid throwing a baseball through your window. All right, so this time becomes very high quality time. Usually in that hour early in the morning or that hour late at night, you really get a lot more accomplished than an hour from 1 to 2 o'clock in the afternoon, especially if the bird is sleeping. If he's sleeping, you get a lot done. Rapidly coming up on a time, and I think it's going to be within a year or two, that we're going to have totally built airplanes, totally built ARFs. John Brodek is already working fast on that. Top Flight's already in the marketplace. And I'm not so sure we're not going to have some parts available too, or wings or tails or whatever. I call it prefab parts. But let's pretend, just to make a wild example up, you're going to build a Strega this winter, which many people are, including maybe Les and I, we don't know. Well, if you look at a Strega, the first thing, if you built it from plans, it'd be a lot more than building it from a kit. Building it from a kit cuts the time maybe by a third. So a kit, if they have a kit, if you build an Impact and you build one of the Ultra Hobby kits or a Falcon, Blue Sky model kits, a kit saves you a lot of time. It also saves time gathering wood. So a kit can be a real time saver if there's a design available that you're happy with. A kit, if there's no compelling reason not to use a kit is a real asset to have in terms of cutting down your building time. Now also, when you have a kit for which prefab parts are available, like for instance with a Strega, very soon, maybe within a week, Bill Hummel's still working on it, we're going to have a fiberglass cowling, and we also have, already, we've probably got 8 or 10 of them over there, the molded top shell. These two parts alone will save 3-4 days, some weight, some time. If you have a plane that you want wheel pants on, like a Cardinal, you can buy the fiberglass wheel pants, already made. Little couple strokes of sanding and primer, and you're ready to go. You see where this is going? If the more of it you can prefab ahead of time, it just means, and maybe in its most extreme case, it means you could at the end of a year have built 2 planes instead of 1. And Jimmy Casale used to build similar planes, and he used to build 2 tails at once, 2 fuselages, 2 wings. He did it in multiples. Well, but if you're using kits and you're using prefab parts, it just means you're able to build more or use your shop time more efficiently. So these are just some of the things that before we actually start our major building projects and we put all this stuff away for the summer, we know that we're getting the leaves falling, and we're a couple of weeks from that. But once we start, the point is, once I start a building season, things go quickly. They generally don't drag along. And we have 3 or 4 other people that would like to build wings or tails or bodies or things in our shop. And so we can, if we can get our stuff done efficiently, it means on the weekends we can help people with their building projects. I think Mike Kajeski, for one, has expressed an interest. Mike Ferguson, an interest. Several people that might enjoy a Saturday at Wendy's in the shop, and we can really push them along on their building program, get them out to the field early next season. So it's just some good random things to think about on a day when the big storm is getting ready to hit.
At the end of the tape, almost at the end, but one final thing that may be a big help to a lot of people is having a building program, and Ken Tyser is a good example. He's built 3 of these planes, now Stregas. When you build the same plane over and over, you develop a rapport with the design, you fine-tune it, and I think the actual construction time is a fraction when you're not building new techniques, new technology. When you build the same thing, I think Jimmy Casale used that to his advantage too. Other people that have built very similar planes and seem to get exceptional results. Anyway, Ken Tyser is, I think, one of the people that's worked his way up the ranks exceptionally fast. He's taken advantage of, and his building time is limited, but he's taken advantage to crank out really nice planes in a very short amount of time by using parts and techniques that he's been very familiar with. The second or third time you build a plane, it goes much quicker. Just some thoughts, and I hope we'll see you on the next video.
Now we're going to run out the last minute or 2 of this tape with what you do during a hurricane. The best thing to do during a hurricane is fly your plane indoors. In this case, we're